and we're Wiki Group 1, and we decided to tackle the topic of underwater noise pollution. So what is the problem? Essentially, the oceans are getting louder, and this is due to increased anthropogenic activity near and around the oceans. That includes shipping, offshore oil drilling, military sonar, and coastal construction, just to kind of name a few. This is a problem because sound travels 4 times more efficiently in water than it does in air, meaning that a sound can be heard from up to 200 or 25,000 kilometers away from its point of origin. This makes sound pollution a global issue and not just an issue around areas of high human traffic. So an overall increase in ambient ocean noise basically affects all aspects of marine life. And that's because sound is a major form of communication underwater, because the euphotic zone is only the top 200 meters of the ocean. And light is not really efficient for long distance communication. Marine animals use sound for mating, defense, hunting, and communication. And when the ambient noise increases in the ocean, these signals are disrupted, meaning the animal needs to expend more energy to simply accomplish the same task. You know, it's kind of like trying to find your friend by yelling their name at a rock concert versus a golf game. You know, one's a lot easier than the other one. So studies have also found that increased ambient noise can cause damage to DNA, internal organs, increase stress, and metabolic activity in animals, stunt animals' growth, and cause internal injury.
How does this problem impact marine ecosystems? Ocean ecosystems are particularly vulnerable to noise pollution produced from human activities such as boat traffic, seismic surveys, and noise from oil and gas platforms. This vulnerability is due to the fact that noise travels farther and faster underwater, as previously mentioned. This increased speed and distance of sound movement often leads to masking of natural sounds within the ocean soundscape that marine organisms use to detect prey, communicate, and migrate. This is especially severe as many marine creatures may rely more on sound than on sight as a main sense, particularly in areas of low light where their sense of vision is heavily limited. The effects of masking have been found to damage communication within species, behavioral patterns, physiology, and overall health of many creatures within the ocean. A specific example of direct impact of human-produced noise on marine life is shown in a study conducted in 2011 on 4 different cephalopod species, which are squids and octopus as pictured, that found that there was massive acoustic trauma resulting in permanent damage to the sensory hair cells of the statocytes, which are used in balance and position, in these species when exposed to high-intensity sounds. The source of these damaging high-intensity sounds was found to be sonar from air guns used on ships used for geophysical prospecting, exploring the seabed, proving noise pollution does cause severe physical damage to marine species. While this study does focus on a particular threatened species, it's important to note that noise is not a species-specific problem, but rather a global problem for the marine environment. Other studies have shown the impact of noise pollution on creatures ranging from right whales down to shrimp. This study, among others, shows that noise pollution has both immediate and drastic effects for many species within the ocean, which will impact the ecosystem as a whole.
Now, the extent of the problem for noise pollution in marine ecosystems, as previously mentioned, communication is really important for many marine organisms. And it's used to communicate between mates or young. It's used to avoid predators for foraging, and this is disrupted in the presence of noise pollution, and it becomes a lot more difficult. Hearing can actually become impaired and cause fish to undergo hearing loss if exposed to enough noise pollution. And even some organisms that aren't directly under the effects of noise pollution can still be affected because it has been found to be a heritable trait. So some fish can be born from fish that are have hearing sensitivity, and then be born with that hearing sensitivity despite never experiencing that noise pollution themselves. Now, one example of the effects that noise pollution has had is on whales. Now, with sonar being introduced in the 1960s, it actually led to a great increase in whale strandings. While there was only 1 reported before the 1960s, there was about 40 reported between 1960 and now. And this is because there's a lot of stress that happens to whales when they experience noise pollution. And that leads them to go through alternate diving patterns, which causes decompression sickness, and that can actually cause brain and heart hemorrhaging. And this leads to just mass strandings. And this just displaces or kills many whales and overall decreases their population numbers.
There are ways we can mitigate the underwater noise we generate. With Canada's Ocean Protection Plan, for example, there's funding that's made available to study the impacts of shipping-related noise on southern resident killer whales. The Port of Vancouver has its own noise reduction initiative. There's a program called EcoAction who gives discounts on harbor fees for vessels that have adopted noise reduction measures. And globally, the International Maritime Organization published non-mandatory guidelines for mariners to reduce underwater noise from commercial shipping. Simple actions like reducing speed, rerouting to avoid marine areas that would be sensitive, or migratory paths, or even maintenance and optimization of vessels. So next slide. Thank you. Commercial marine traffic is one of the main sources of anthropogenic underwater noise, and cavitation from propellers, that's shown in the picture here, has been identified as a main culprit in noise radiated by ships. And cavitation occurs commonly, but in excess, it can cause unwanted wear and noise when the air bubbles collapse. It's possible to reduce noise by adjusting the propeller and hull design or the machinery configuration in the ship. And there's noise protection models that exist that can help ship owners, shipbuilders, or designers to find the right noise control measures by analyzing noise sources on ships and the pathways of transmission. And examples of noise control measures would include variable pitch propellers, vibration isolation mounts, or structural damping, for example. There's definitely a lack of awareness about underwater noise, partly because it's invisible, but it is known to be harmful to marine life, and it has increased tremendously in intensity with the increase of economic activities, global trade, and marine traffic since the 50s. Except for the 2020, there's been actually a downward trend this year since the pandemic, and the response is being studied by many, one of them being the International Quiet Ocean Experiment. There are technologies to reduce underwater noise pollution strategies that include reducing and optimizing marine traffic, and there's always room to rethink our own consumption habits. Thank you.